Hey there, this is the PySpace theory video. I recently blogged that in the PySpace theory, if you blow air over any surface that's say horizontal to gravity, it doesn't have to be aerodynamic. The mass of the object will move up towards moving air, right? There's plenty of examples of Bernoulli's law out there and so on, but according to the PySpace theory, it's the surface area of an object which moves up towards the moving air. It's not air pressure underneath that forces the wing up. It's actually the mass of the object that's interacting with the moving air. According to the PySpace theory, if you move air pretty fast over a surface, what will happen is that the moving air would be up here, that the mass of the object will move up towards it. It's a similar idea to wind moving from high pressure to low pressure. In the theory, low pressure is just smaller particles, relativistically smaller particles, so it moves towards them, and center of gravity, so in this room things are moving this way towards the center of gravity where things are smaller. So if you make things smaller above an object, you either by velocity or pressure, they're both intertwined with one another, you'll get lift, right? Now you have to apply enough lift, but the principle should work here. I should be able to demonstrate that principle here and now and not use any fancy laboratory to prove it. So I have a kitchen scales. It's 561, I think, grams. This book is, and that's just a light source there. And you can see it's pretty constant. Then what I do is I just get a hairdryer, just a regular hairdryer. You can turn it on. It just blows air, and so what we're going to do is I'm going to blow air. I'm going to blow air over the book. Okay, I'm going to blow it over the book. I'm not going to blow. I'm going to blow the air in such a way that it doesn't touch the book. Right. So let's just try and do this right. Hang on. I have to reset it. Okay. So resets to 0. I drop the book on. There's no particular way that you drop it on. 561 grams, and then I'm gonna try and do both. I'm gonna try and show both. 562. So I'm just gonna blow. I'm just gonna turn it on now. You can sort of see I'm not touching the book. I'll point it up a bit and then I'll level it off. Take it up. I'm just taking it away, just bringing it down. So in theory, what's happening is, now this is theoretical of course, what's happening is that the moving air has associated quantum wave functions which are embedded in the streamlines, and the mass of this object is attracted to them. Yeah. Now, if I can do a. Now, if you blow the air directly on the book, you'll get the full force of the air. So you know that's Newton's third law. And this is more kind of in the Bernoulli space. I hope you can see nothing's touching. It's just a flow of air. So the basic idea is, I propose the lift mechanism. It's real simple. You just have to get a flow fast enough above a surface. That's all you need to do. It doesn't have to be shaped like a plane wing. It doesn't. You know, the aerodynamics are important for a plane wing, but you don't need a plane wing to produce lift. And to a certain extent, that's what the Coanda effect is about. Some people might argue what I'm demonstrating is the Coanda effect, but basically what I'm trying to show is a application of the pi space theory. If you could make this airflow fast enough, that book would lift, right? That book would lift. In later lectures, I'll talk about how much speed would you need to lift so many grams, so many newtons of energy. But basically, that's the principle. It's really, really simple. I don't think it could be any more simple than that. That's how you produce lift, through movement. You don't need a plane wing here. This is a book. This is a book. This is a book, right? And I didn't touch it. Okay, that's as simple as I can explain the principle. That's it for now.